Hey folks. So in this video, I wanted to go through the example from class where we had the function y equals the square root of x. And we were going to rotate this around the x equals -1 vertical line. And we talked about how there are several interpretations of what the volume should be, and how each of those different interpretations would give us different volumes to try to calculate, like different integrals to set up. And so, okay, I want to go through all those different interpretations and walk you through how I'm visualizing and how I'm, coming up with these different calculations. Okay, so let's go ahead and get started. The first one I'm going to do is the one that's shown here. I have, putting my pointer, there we go. So we have a region which is above the graph y equals root x, and then fills in all the area to the left of that until the line x equals -1. So I'm gonna, rotate this around that line, x equals -1. And one way to do this that I like to think about is like imagine taking a single point on this curve and then just like slowly like kind of like bringing it out of the page and then rotating it around, right? Making a big circle all the way around, sort of in three-dimensional space. So like it's coming out towards me. Oh, I made it too slow, so now it thinks it's a straight line, sorry. So if I'm coming out towards me and then out to the other side, and then it's going like out in the back and then coming back around. Okay, so that's like my circle that's kind of happening in three-dimensional space, sort of perpendicular to the page, right, itself. And if I did that with all the points, I would get some sort of, opposite looking shape on the left-hand side of my picture. And then what I want to do is I just want to fill in this circle, right? And say like this is the sort of typical cross section, right? So this is supposed to be a flat circle, right? That's kind of what I'm envisioning here. And then my actual shape, my entire solid that I have is sort of all of the, this whole region, sort of like this almost like a bowl or something shape that I have. And yeah, it's all completely filled in, right? The way we set this up, all of it's filled in. And so when I think about my cross section, this circle that's in the cross section, I notice that this truly is like a full circle, a disc, not a washer. And so if I need to calculate what is the area of that circle, okay, so in this case, I have a circle. And so the area of that circle is, of course, pi r squared. And so I need to know what is that radius, right? So in this case, I need to know, I can draw like a little line like this to say, okay, the radius r should be the distance from the dotted line, that's the center of the circle, out to the line y equals x squared. Okay, well, first of all, something I notice is that because I have a vertical line that I'm rotating around, when I integrate, it's going to be a dy integral. This is true for all of the problems. I have a dy integral. I'm integrating from y equals 0. This is in the problem statement, up to y equals 4. And so because of this, I'm going to need to rewrite my function as x a function of y. So x equals y squared. Okay. And so, okay, so now what I need to do is really think about what is that radius in terms of this function. I'm going to zoom in a little bit on this. And so I'm looking at the distance from this first dot, which is on the dotted line, out to the edge of my circle, which is on the line x equals y squared. So if I think about what is y squared itself, right, the x equals y squared function, well, okay, yes, it is this function, but that y squared only represents the distance from this function to the axis, okay? And so when I think about that, well, the y squared will get me basically that little piece. And so to actually get all the way back to the center of the circle, I have to say, well, what's the distance that I'm missing? I'm missing here. And that's from the axis to -1, which is, of course, length 1. So overall, what I have is my radius is 1, and then this little piece here is y squared. So in total, y squared plus 1 is the distance. Okay, so it's a lot of work, right? But we're going to use this idea over and over again, so I want you to try to do it carefully. So my area of my circle is pi times y squared plus 1. And then that was my radius, so I square that. Okay. Now, once I've figured that out, I can set up my volume integral. Its volume equals integral from, okay, y value. So y starts at 0, goes up to 4. And I'm integrating my disks, so it's pi y squared plus 1, quantity squared, dy. Okay, that's it. Okay, so let's go ahead and replace this picture with the next version, which was what if we had done a picture like this? So now this time you'll see the only difference is that I didn't fill in right over here to the left. So I'm going to rotate just from right the curve to the axis and then still rotates over the same x equals -1 line. And so let me, again, I'm going to try to sketch what this looks like. Now, what I'm noticing is because there's a gap, right, in my picture, when I go to rotate this region around the axis, there's going to be a gap in my certain like in my cross sections, which means I'm going to have washers, not disks. Okay, so what do my washers look like? Well, let me try to play the same game I did last time. I'm going to draw sort of imagine a single point on the line. Again, this is the line y squared equals x. So I imagine taking this point, and then I'm going to start rotating around the line x equals -1. And so if I go out of the page and then back into the page, and then I got the back. Okay, so I get something like this, right? So I'm going around that, made a big circle, big loop. Um, and now the thing is, right, I'm not shading in. This entire circle isn't shaded in because, well, it ends here, right? So from if I took this line, which is just the axis really, and I rotated that around in the same way, what I get is a little inner circle. And what I recognize is that, okay, so like this region was all like what was shaded in before, like that was the blue region. And then I took that and started sweeping it around, right? So what I'm getting is this nice washer shape, which gets like kind of dragged all the way around. And I could do that for all the different levels. And so when I stack all those up, I get a similar sort of picture as last time, where I'm going to have, let's see, nope, sorry. Something like this. So on this picture, it's kind of hard to draw. I'm only sort of drawing the left and right side, but I'm going to have this region that gets swept around, forming these nice washers. And that I've drawn the sort of that red shape in the middle. That's the typical cross section. Okay. And really, like the biggest idea is trying to draw that cross section so that I know how I can start calculating inner and outer radii. Okay. And so let's go ahead and do that. I need to calculate the area of this washer, which amounts to calculating the radius of both the inner circle and the outer circle. So the inner circle is actually easier to do here because the inner circle, right? If I think about, what's the distance from here to here? Well, that distance is the same, right? If I think about all the different ways I can go from this dash line to this axis line, that distance is always exactly 1, no matter where I am. So this inner radius is always going to be 1. All right, let me go ahead and just keep track of that. So my radius of my inner circle is always 1. And now what's the radius of my outer circle? Well, look, the radius of my outer circle is exactly the same problem we just did. The distance to the outer circle is the distance from that dotted line out to the curve, right? These are my outer radii. It's the distance from the center of the circle out to the curve y squared equals x. Okay, so how do I calculate this distance? Well, I need to have the distance, again, the distance y squared is the distance from the curve back to the axis, and I add 1 to that to get back to the center. And so the radius of my outer circle must have been y squared plus 1. All right, once I have those calculated, I'm pretty good to go. I can now set up my volume calculation. It's the integral from 0 to 4 as usual, right? Again, this is because I'm starting at y equals 0 as my bottom limit, and then I'm going up to y equals 4 from the problem statement. And I'm going to integrate pi outer radius squared, so that's y squared plus 1 squared, minus pi times inner radius squared, which is 1 squared dy. Okay, then that looks good. Set up. And we can, evaluate this, of course, by doing some sort of expansion, right? Distribute the first term and just start calculating stuff. But okay, we don't have to go through that. Last one. Okay, last one. Yes. So now, okay, so I have this region here, which is shaded below the curve. Again, y squared equals x. And okay, I'm going to rotate this around the axis. Okay, so let me again try to draw. So if I'm doing that, right, what I'm realizing is that really now the outer radius is this line, really, right? I'm going to take this line and like start sweeping it around the axis, right? X equals -1. Here's my x equals -1 axis. I'm going to rotate that around. And so if I took a typical point here, and then imagined, okay, so this is gonna be a big circle, so I wrap it all the way around. Goes all the way around, right? Like here, okay. And then what's my inner radius? Well, all of this region is shaded in up until, right? So all of this is shaded in until I get to here, and then it stops being shaded in. And so that's the inner radius. That's where I'm no longer gonna have anything to rotate around, right? And there's no more volume there. So I'm gonna draw my inner circle, kind of looping around the same way. Okay. And then I'm going to try to go ahead and same thing. I'm going to try to fill in my my picture. So I have something that looks kind of like this and this. And I've sort of shaded all of this in, right? And again, I have this big washer, right? That's getting swept around. Let me write down my red picture, right? So my red washer. And it got swept around. Okay. Alrighty. So this is my cross section. Again, it's a washer in this problem. Let's go ahead and calculate some radii. So what is the inner radius this time? So the inner radius is the distance from the axis, the center, right? X equals -1 out to this point. That's the inner radius. And so that is the same calculation we did before, isn't it? So the inner radius is 1 plus y squared plus 1, right? One more time, 1 gets me from -1 to 0, and the y squared gets me back to that curved line, right? So that's those distances. Okay. And now what is the other distance I need? Well, the outer radius is the distance from here all the way out to this line. So the outer radius is actually always the same for all these problems, or for all these washers. And so the problem is, how do I calculate, right, what this line is? Well, this is a little bit tricky, but the thing to remember is that we were given from the problem statement that I'm integrating up to, right, y equals 4. That's the top, right? Which means this point is some x, comma, y equals 4. And so you say, so you ask, okay, what is the x that goes with this? Well, you look at the equation that was given. You say, well, y squared is x. And so if I do that 4 squared, that's my x. So this point must be the point 16, 4, which means this vertical line happens at the line x equals 16. And so now I can see the distance from the center of my picture out to the edge where the x equals 16. That distance is, well, 16 plus 1, so 17. So my outer radius in this problem was 17. And again, with that, I have enough to finish my calculation. I have my volume in this problem will be 0 to 4 integral pi times the outer radius squared, so that's 17 squared, minus pi times the inner radius squared, so that's 1 plus y squared squared dy. We're good to go. Okay, so my drawings aren't beautiful. I highly recommend checking out the worked out example. These same examples worked out on Canvas. I used a program to make very nice looking pictures. It's a little easier to see what's going on. But hopefully between that and with this, you have a better sense of how I'm visualizing and how you can start getting more confident visualizing these disks and washers and setting up these integral calculations. If you have any questions, let me know.